Hello, let's understand linked list. Now, before we do that, we need to have a little bit knowledge about array. Otherwise, we won't be able to understand why linked list was introduced and what's the advantage of it, and in what use case we should use linked list. So, in order to understand those, we need to have a little bit knowledge about array. There are certain properties of array that both gives it the advantage and disadvantages that array have. So, if you see that on top, I have mentioned memory location, and if you see that all these memory location have like equal distance between them. So this is one property of array. This makes sure that random access is fast. So if I want to access this third location in this array, I won't have to like uh, uh, go one by one. I can directly, if I know the location of first element of this array, I can directly go to third with some simple math without looping through all of the elements in this array. Okay, this is one advantage. But there's also a very big disadvantage. That is, if I want to insert an element in the middle of this array. So if you see, if I want to insert an element between uh, zeroth and first element, so one more thing to note that every time the index always starts from 0, not 1. Okay. So if I want to insert an element between zeroth index and first index, then I will have to move all the other element out of the way first and then insert it. Okay. So this gives linear time complexity. That is, if let's say you have like a million elements after this, then you'll have to move all of them individually, and this is time complex. This is computationally expensive. And same thing with deletion, like delete operation. We'll have to move all the elements that are after the index that we want to delete one step left. So yeah, this is the main limitation of array, and this is what uh, linked list is trying to overcome. Okay. So this is the structure of linked list. So linked list is a data structure where in each individual node we have the value of this element and the location of the next element. So it's like, so we only store the location of our head element of our linked list, and this first node is called head element, and then the head element have location of the next element in our linked list, and we traverse this list in this way until we find a node where the next element location is set as null. Okay. So to sum up, in linked list data structure, we have a node, and in each node, there will be the a pointer that points towards the next node and the value of this node. Okay. So this is the pointer that points towards the location of next node, and that goes on. Now, so why did we do all of this? What is the disadvantage? What is the advantage of doing it in this way? So let's say we want to insert a new element at the beginning of this linked list. So how will we do that? If this was a array, then we'll have to move all the elements one step towards left, and this will give like linear time complexity. But since this is a linked list, what we can do, we can simply just add another. We can simply just add uh, another node, and now this node will be the head of this linked list, and there will be just a pointer. Okay, so I've accidentally brought this the wrong way. So the arrow should be pointed from this to this. Okay. So let's fix this real quick. Right. All right. So in linked list, we just add another node and set that new node as our head, and so we don't have to move all of these other nodes. So if you have a big linked list, then you can see that this will lead to only constant time complexity instead of like linear time complexity. And in a similar way, let's say you want to insert at the end of this linked list. Here also, what you will do, you will just add another node at the end of it, and just instead of the previous end node which had null pointer, which is pointed to null, which indicates that this is the end of this linked list. The null will be replaced with the location of next node, and the next node, which is the end node, will have null. So we traverse through all of this, and then we at the end, when we reach null, we say that the linked list has ended. Okay. Now what happens when we want to insert an element that is like at the middle of this linked list? So the same operation as this, where we had linear time complexity. So the same operation as this. So here we just simply add another node over here, and then change the add another node over here, and then we change the pointer. So now it points to, so we add another node. So now the head node points to this node, and then this node points towards our next node. So in this way, we don't have to worry about. So this is also happening in like constant time complexity, and we don't have to move any other node in this linked list that don't need to be changed. Okay. So in similar way, the deletion of linked list is also very simple. We just simply um, yeah. So we just simply previously uh, this B node was pointing towards this C node, and then this C node was pointing towards this D node. Uh, but we can simply, if you want to delete this C node, you can simply make sure that this B node now directly points towards this D node. Okay. And how will this be pointed? So previously, what was the case, that this 2000 was the location of this next node, and 1020 was the location of this C node. So what we will do, we will just update this 1020 to 2000. Okay. And when we do that, that means that and to 2000. And when we do that, that essentially means that we are now pointing directly to D node from B node, and the C node has no use. Okay. And this is what we call singly linked list. But there are some other types of linked list. We have circular linked list. It is similar to normal linked list, singly linked list. It's just that the last element points back to the first element. So we just kind of go in a loop. Okay. And there's also a doubly linked list. Here, uh, this is done in use case where you need both. So this is done where you need to traverse both from front to back and back to front. Okay, so the difference between singly and doubly linked list is, previously there was only uh, the element of the node, like the value of this node, and the location to next node. But now, along with, we also have location to last node. So this can be traversed in both way, both front and back. Okay. Now here are some advantages of linked list. One is dynamic size. That is, there is no limitation to size, and also there was one limitation of array. That is, when we create an array, let's say we are creating an array of 5 elements. Okay, so when we create this array, we already uh, leave, like, allocate memory worth, let's say, 10 element to this array. So this array only has, let's say, 5 element, but there is also like 5 more element space that is blank. So later on, when we need to insert more elements of this array, we can just use up those blank element space, like blank memory spaces. But what happens when our array becomes bigger than uh, the amount of memory we have, right? The amount of memory chunk we have? So in array, as you can see that the locations are contiguous. So what happens when we do not have more contiguous memory slot? So what we need to do, we need to copy the whole array to another memory location, where this time instead of, let's say, having memory worth of 10 element, we will have memory worth of 20 element. So this is an extra step that needs to be performed when the array becomes too big. But this kind of issue is not do not arise with linked list, because the memory location are not contiguous. So if I want to add another element over here, and we do not have contiguous memory, so we can just, like, if the 2600 memory location is not available, we can put this node in like 8000 memory location. So that is not an issue. So when do we need? So there is also some disadvantages of linked list, and we need to understand that when do we implement linked list and when do we implement array. So I so in use cases, that are very big disadvantages or disadvantage of linked list is that we cannot directly access any element in the linked list. So if I want to access, let's say, this C element, we first need to go to this A element, and then traverse to uh, then traverse to one second, and then traverse to this X element, and then get the memory location of next. This is B, and then C. So accessing or searching through a linked list is more expensive operation. Like computation is expensive operation because it's linear time complexity. Uh, so in use case where you have to you have to do very frequent search operation, linked list is not preferred. In that case, you need to use array. And yeah, so random access is good with array. And also, uh, if you see that we need to store both the value of this node and the location of the address of next node, and in doubly linked list, address of both next and the previous node. So as you can imagine, this will result in more memory usage. And so this is one disadvantage. And now let's implement some linked list and see what's how is it going. Okay. So although in Java and Python we already have built-in linked list classes, but I have defined a linked list just so that you understand the um, what happens under the hood, the operations. Okay. So at first we need to define a node, and in a singly linked list, as I discussed, we have only the data part of the node and a pointer that points towards next node. Okay. And I will run this, and then we will run this. Yeah. As you can see, at first we are appending 1, 2, and 3, and let's put a display over here. Copy, and you can see the first element is 1, second element is 2, third element is 3, and then there is none. This is null pointer that says that we have reached the end of this linked list. And similar way, we are inserting an element at the first index. So this is 0 index, this is first index, so we inserted 4 in first index, and then we are displaying it, and we are deleting whatever it is in index 2. This is here, and yeah, like that. And I've also implemented doubly linked list. So here you see that we have data. In every node we have data, and we have a pointer that points towards next node and the pointer that points towards last node. And in a similar way, you see, yeah, same thing. And circular linked list again, same thing. Okay. Let me know if there was any issue. And yeah, and yeah. Have a nice day. Bye.